And if you look at the cells in culture, they only have a certain finite number of divisions. And that's true of every cell from the human body or from any other organ of any animal that you would culture in the laboratory. Is you only get a certain number of divisions and then the cells die off. Stem cells are different. They in fact continue to replicate, and they replicate infinitely because these cells have no really inhibition of cell division and cell propagation. And remember, they're not differentiated. So this is great because these cells are valuable because they ultimately can be turned into any kind of cell. They remain unspecialized with no specific function, but can be specialized. I'm going to come up here, Tony, like it or not. Okay, that's good. You okay where I'm at now? All right, good. Now, we're going to define these cells a little bit further. This is very important. The totopotent, toto meaning altogether potent stem cell, is one that's present after 3 to 4 divisions of the fertilized egg. So when the egg gets fertilized, you have 3 or 4 divisions, and these are cells that can become even the placenta. Remember, you know, a pregnant woman has to feed the baby, and the placenta is the organ that does that. Cells at this stage of embryogenesis are cells that can become the placenta in addition to the new life that God has created in the womb. The pluripotent stem cell, we're going to return to this word several times tonight. The pluripotent stem cell develops all human cells, or has the capability of doing that, other than the placenta. So after a couple more divisions, after that 3 to 4 division stage of early growth and development, now we can't make a placenta any longer out of these cells. So those cells that can become the placenta are already gone. There's no capability to form the placenta after about 5 or 6 divisions. Those are called pluripotent. And the multipotent stem cell can differentiate, but it has limited cell types. Remember when he said if we take a brain cell, it can form, or brain stem cell, it can form other kinds of brain cells? The brain just doesn't have one kind of cell. It has a number of different kinds of cell types in the brain. But you don't make a heart cell out of this multipotent brain cell. That brain cell has the capability to differentiate, but only into brain cells. So these are the terms that scientists use to describe these various cells. Now, ultimately, this stem cell, this pluripotent stem cell that has the capability of becoming any organ, could differentiate into approximately 250 different types of specialized human cells and tissues. Are we not fearfully and wonderfully made? God has created 250 approximately different cell types in the body. And you know, the more I do science, the more I'm thankful for God giving me a glimpse at what He's created. And the more I learn, the more humbled I get in terms of what you don't know becomes more evident the more you know. It's a humbling experience to do science. And I'm thankful for those few believers that exist in all forms of science: astronomy, biology, physics, chemistry, because we have a different perspective on creation than, in fact, the scientists you saw on this screen. Now, I don't know anything about their faith, but I presume they're working from an earthly viewpoint and an earthly perspective. They were critical, at least some of them were, of the Bush policy of limiting stem cell utilization. It was said in Science magazine, you saw a glimpse of Science. Science I get weekly. It's kind of one of the major journals of scientific discovery and furtherance of not only biomedical science, but earth sciences, oceanography, astronomy, etc. In 2001, it was said that 3,000 Americans die every day from diseases that in the future may be treatable with embryonic stem-derived cells. How's that for a political statement? Looks like a good thing to put in a grant application, doesn't it? You know, if my embryonic stem cell research could be funded, we could cure all these human ailments. Well, it may not be totally wrong, but anyway, this statement could be challenged a bit. Now let's look at this in a little bit more detail. You saw this a bit in the video, but basically the fertilized ovum then has a few divisions, and then you form what's called the blastocyst. And the blastocyst is a form of the embryo that ultimately is sufficiently early that those are the cells that we would call pluripotent. So cells taken from that stage of embryogenesis can form all of the organ systems shown at the bottom, including what do we have here? We've got cardiac muscle, and we've got blood, and what's on the left? I can't really see that. What is that on the left? Nervous tissue? Anyway, all the potential organs of the body can be formed at this stage where cells are called pluripotent. Now, let's drill down a little bit in terms of the types of stem cells that are available. The first is the embryonic stem cell. These are from blastocysts, from the fertilized ovum, and they're basically left over from in vitro fertilization donors. And we're going to return to this in an area of more discussion near the end. So these are couples that have gone to get implantation of an ex vivo fertilized ovum to put back in mom to carry the pregnancy to term. Now, when you place fertilized eggs, embryos back into the mother, they've already undergone a number of divisions. So those embryos that have not been used for in vitro fertilization or implantation are those that are available. Now the issue here is ultimately, is that a life? And George Bush, and many of us I would think, that's a life. That's a fertilized egg that's now been put in the freezer, but if allowed to propagate or implant, it would be a human being. And then we have a second source of embryonic stem cells, and that's from aborted, I call them babies. The scientific community calls them fetuses. I mean, the term fetus, I think, gets around the issue that we've got a life here that we're dealing with. This is some kind of mass of cells that's kind of growing and developing. And you notice a couple of the scientists, one in particular said, well, there's no organs, there's no tissues, so therefore I'm going to kind of ignore the fact that if this blastocyst was allowed to continue to propagate, there'd be a life that would be formed from that. Keep that in mind as we go ahead. Now, the adult stem cell is a kind of a different animal. This cell can be obtained from any organ system of the body. And I'm going to give you some hope about this area of science near the end of the presentation, that ultimately we can get these stem cells from skin, from hair